All right, guys, we're on lesson 3 now. We're on final forces, all formulas. We're calling it final forces because this is the final lesson we have, and we're just going to do a general wrap up to make sure we're all on the same page. I know we're like super tired of forces and it's becoming monotonous and the same thing, and we're going crazy. So this is our last lesson before we take some assessments and enter our next unit. So on our agenda, we're going to look at force, speed, velocity, and acceleration like we have been. We're going to look at keywords, routines, how to solve, and units for each. I'm not going to read each bullet point because it's the same thing. I don't want to drive us crazy. We're already crazy because we're inside, right? So that's that. Force. So keywords. Obviously, if a question's giving you all this information and the last part of the question says, what is this object? What's the object's net force? So what's the amount of force being applied to this object? That's a keyword. You want to highlight that. Mass and accelerations are evidently parts of the keyword because it's parts of the formula. Force is mass times acceleration. We need those keywords. You need to circle those so we know what we're looking for. And then last but not least, emphasis on not least, because you need to put these at what's your answer with units? Newtons. 28 newtons were used to apply force onto this object. I want your answers with units. All right. And we'll see that in real time, in real life. And when we get to the second slide, and then this information here will be right next to the example so we can look back and forth as a reference point. So annotate mass and acceleration values. Choose the force formula, obviously, because we're solving for force. Write the equation by substitution. Answer and solve with units. And those units are what? We just talked about it. Newtons or N. So you can put 100 N or 100 newtons, whatever. Just signify, let me know that you know that force is measured in newtons. Great. Let's take a look at this example on the right-hand side. How much net force is required to accelerate a 2,000 kilogram car at 3.003 basically meters per second squared? So let's first highlight our keywords, net force. How much net force? So we know they're asking how much net force. This is what we're solving for. Then it says 2,000 kilograms. Kilograms is the weight of something or the mass. So that's mass, right? And then 3.00 meters per second squared. That squared is a dead giveaway. Acceleration, that's our acceleration value. 3 is our acceleration. 2,000 is our mass. And we don't know what our net force is. So that's why we have that question mark there. We don't know yet. We need to solve for it. So we chose our formula, which is F equals M times A, which is basically force equals mass times acceleration. We substituted for mass. What number did we substitute for mass? 2,000 kilograms. Then for acceleration, we got 3 meters per second squared. So we put that and substituted that into that place. So now we know that we have to do 2,000 kilograms times 3 meters per second squared. Easy math. What's 2,000 times 3? 6,000 what? What's our units for force? Newtons. If I'm lazy, I'll just put 6,000 N. That's easy. They'll put 6,000 N's because that doesn't make sense. Just put 6,000 N. All right. Now we're on speed. So let's talk keywords for speed. Obviously speed, because that's going to be something that we're going to be looking for in the question. Distance, which is usually measured in meters, miles. It could even be feet, etc. Time is usually second or hour. So let's go to the right side of our page again. A dog runs from one side of the park to the other. The park is 80 meters across. The dog takes 16 seconds to cross the park. What's the speed of the dog? Now, you guys that are scared of dogs, this should be a dog that you're scared of because this dog is fast. All right. So our annotation should look like 80 meters because that's our distance. And 60 seconds is our time, right? And we highlighted speed because that's what we're looking for. What is the speed? So we have a question mark for speed because we need to find out what speed is. The distance is 80 meters. The time is 16 seconds. We substitute that into distance divided by time. Our distance was 80, so we do 80 meters divided by our time, which was 16 seconds. 80 divided by 16 is 5. But you can't forget those units there. Those units say meters and seconds, so it's 5 meters per second. I wrote it out here. You don't have to write it like that, but I wrote it out here so you remember what these units mean. Now, if we go back to the left side, it says the units may vary because here it says meters and seconds. But what if this said miles per hour? Your units here will be 5 miles per hour as opposed to meters per second. So you got to pay attention. That's why I highlighted the whole thing. I didn't just highlight 80. I highlighted 80 meters because if this said miles, I will have to put miles per second. Or if this said hours for 16, it would be 80 meters per hour. All right? So, velocity. Keyword is velocity, obviously, and it's the same thing as speed, but the difference is direction is included here because we're talking velocity. So you're either going to look at north, south, east, or west, things of that nature. And even here at the bottom, the units vary, like I said before. Pay attention to the meters per second or the miles per hour, or it could be any of those. A bunch of feet per hour, kilometers per hour, kilometers per second. There's a bunch of them. So that's why when we annotate number 1, a part of our routine, we annotate the whole thing, 60 meters. But here we got to talk about velocity, so we're talking about direction. So you're doing 60 meters north. Then we have our seconds, 20 seconds, that's our time. And then we circled velocity because it's asking what is the velocity. So we know velocity got a big old question mark because we don't know what the velocity is yet. Not just yet, right? Our distance is 60 meters and our time is 20 seconds. Now, we do our substitution down here after we get our formula. 60 meters north divided by 20 seconds because we substituted 60 for the distance and 20 for the time. So 60 divided by 20 is 3 meters per second. Where? North. We're talking velocity. Don't forget that direction. Same thing as speed. Just include the direction after your units. Acceleration. Keywords, final, initial, from, to, velocity, time, all of that, right? So from or to is kind of tentative. Sometimes you see it, sometimes you won't, but it's helpful though. If a word problem is written that way, you're like, ooh, to, from, I know where the initial and final is. Because if it's going from, that's the initial point, and it's going to, that's the final. So you'll be able to make that decision more easier when you have those letters. I mean those words. But this question that I provided doesn't have that, just as an example. So we're going to go into that. And velocity and time are definitely important as well for keywords. At the bottom, the units usually vary, but it's always squared. So like I said before, it could be miles per hour squared, meters per second squared. Just make sure your square is here. All right. So a cyclist begins warming up in the race by traveling 10 meters per second, and at the midpoint reaches 25 meters per second in 5 seconds. How much did the cyclist accelerate? So we annotated 10 meters per second, 25 meters per second, 5 seconds, and acceleration. Acceleration, we have a question mark because the question is how much did the cyclist accelerate? So we don't know that yet. Question mark, right? Final velocity is 25 meters per second. Ms. Reed, how did you get that? So if you're reading it, use your ELA skills. They begin warming up at 10 meters per second. Beginning has to do with starting point. Starting point has to do with initial, right? So we know that can be it. But at the end, it says, and at the midpoint, it reaches 25 meters per second. So we know that the initial is 10 meters per second because the cyclist begins. That's the key word. It begins and it starts at 10 meters per second. So that would be our initial velocity. So our final velocity could only be 25 meters per second. And the easiest part is 5 seconds, and that's evidently our time. So below that is the formula here. Acceleration equals final velocity minus initial velocity divided by time. We're not saying over time anymore. We're saying divided by time because we're talking math. So our final velocity gets to be substituted here as 25 meters per second minus the substitution of our initial velocity, which is 10 meters per second, divided by 5 seconds, which is our time. All right. So 25 subtracted by 10 is 15. 15 divided by 5 is 3 meters per second squared. All right. So that concludes our wrap up for all of this. If you feel like force, speed, velocity, acceleration formulas are tricky, take the time to pause your video and rewind and go back to a particular part to brush up and refresh yourself on it so you can feel more confident about it. Otherwise, we're going to move forward. For our check for understanding, what is the difference between the units for force and the units for speed, velocity, and acceleration? What makes them so different between force and the rest of them, right? So A, nothing. They all measure something, right? That's the answer one of you guys would give me in class. Whatever, it just measures anything, whatever, who cares, right? B, force is always measured using the unit newtons or Newton, and the rate remaining can vary. Sounds like a pretty good answer. C, they are all the same. What do we think? Give you 5 seconds. So the answer here is B. Force is always measured using the unit newtons, and the remaining can vary. We had that conversation throughout the lesson. They can be miles per hour, meters per second. They can be feet per second, whatever the case may be. Just gotta pay attention to those units that are given in the word problem so you know what to write, which units to write in your answer. But force, we're always doing newtons with force. Force is always measured with newtons. So maybe that was a misconception or we looked over it. So this check for understanding is really important for you to pay attention to, okay? I was right. Good. All right. So now that we concluded our lesson, head over to Google Classrooms and do that exit ticket. If you have any questions, like I say in the previous videos, feel free to email Ms. Johnson, Ms. Wilson, Ms. Vera, or myself, Ms. Reed. You can leave a message in Google Classrooms. We would probably prefer emails. I'm on the Remind app, and also there is a science Instagram page for you guys. So if you have any questions about that, please, or about the lesson in general, or any previous lessons, or what we're doing going forward, or reaching any type of materials or tools or assignments that you need, please reach out to me. And you're at home with your parents, they have my number. They can give me a call as well. So please do not hesitate to reach out to me. I'm going to be sending reminders about assignments and assessments and projects and things like that through Remind as well. So just, if you don't have the Remind app, email me and I'll send you an invitation and you can go forward in that process as well. Thank you so much. See you guys next time.